Hello everyone, my name is Abel and the title of my talk is HK-band interferometric imaging of the Mira star R-car. These are the names of the collaboration team. Our goals are to perform interferometric image reconstruction of the Mira star R-car using H-band data to map R-car's surface, in particular giant convection cells, and K-band data to map the inner circumstellar envelope composed by the continuum plus the CO bandheads. We want to establish physical parameters such as sizes, temperatures, and optical thickness, and we want to constrain the mass loss mechanism in oxygen-rich AGV stars, which are not well constrained yet. These are the characteristics of R-car, the star that we are analyzing with interferometric imaging. This star is very important to study given that it is very bright in the near infrared and also is at a short distance with respect to other AGVs. We perform our observations with gravity and PIONIER, which are part of the very large telescope interferometer VLTI. You can see here and here the characteristics of each instrument. In this slide, I'm showing you the interferometric observations carried out with each instrument. In the case of our gravity observations, we applied a spectral rebinning to only 8 spectral channels. Also, we separated and analyzed our data into 2 epochs, January and February. These are our gravity observables, squared visibilities, and closure phases. Each color corresponds to a different spectral channel. The UV coverage is presented in this slide. Again, each color corresponds to a different spectral channel. Here, each point corresponds to a different baseline and orientation. The high spectral resolution of our gravity data allowed us to resolve the 2 CO bandheads that you can see in red ellipses. The drops in visibilities with corresponding closure phases different from zero indicate that the regions where CO is present are more extended and more asymmetrical than the continuum emission. In this slide, I show you the PIONIER observables, squared visibility and closure phase, and the UV plane coverage. Each color corresponds to a different spectral channel. In this slide, I show you 2 examples of our reconstructed images in the continuum at the same spectral channel. As you can see, there are differences between one image and the other. The January image presents a spot towards southeast, while the February image presents a more elongated structure. We used plots like these ones to verify the quality of our reconstructed images. Here is an example which shows the agreement between the reconstructed image in red and the corresponding data in black. In this slide, I show you some examples of our best reconstructed images across the first CO bandhead, centered at 2.2946 microns. Again, the difference between January and February are evident. The velocities are an indication of the gas moving towards us and far from us. Now, in this slide, I show you 2 examples of our best reconstructed images, but across the second CO bandhead. Again, the differences between one epoch and the other are evident. Now, let's talk about our PIONIER data analysis. Our best reconstructed image is shown on the right, while in the left is an image reconstructed in 2014. This image was taken from Monnier et al. We can see that there are differences both in size and in the structures present on the surface. If we compare our gravity and PIONIER images, we see that the size is approximately equal to the spots in the center of our gravity images. So, we might be observing giant convection cells, but with a lower resolution than the PIONIER images. Also, we can see that there is a bigger structure surrounding the surface of the star. This might be an indication of the inner circumstellar envelope that we are studying. As I mentioned in the beginning, we want to obtain the size and contrast of the convection cells present on the surface of our star and compare them with models of the stellar convection. The image on the right shows a relationship between the size of the convection cells and the temperature of the star. Performing this analysis in R-car will allow us to set a new point in this plot, which will help us to establish a more general relationship between the position in the HR diagram and the size and temperature of the convection cells. Finally, we want to obtain an estimate of the size, temperature, and optical thickness of our car's circumstellar envelope, using, for example, a thin layer model. Thank you very much for your attention.